There's a photograph that astronauts don't like to talk about, not because it's classified, not because it shows something disturbing, but because of how it makes them feel. It's a picture of Earth taken from the International Space Station. Beautiful, yes. The blue oceans, white clouds, green and brown continents, stunning. But if you ask astronauts what they actually felt the first time they saw Earth from orbit, many of them don't say wonder, they say fear. Not the fear of being in space, the fear of seeing home from the outside. Because once you see it from that perspective, once you really look at it, you realize something you can't unrealize. And it changes everything. Here's what they see that you don't. From down here, Earth feels infinite. Endless horizons, vast oceans, mountain ranges that stretch for thousands of miles. There's always more land beyond the horizon, more sky above, more world in every direction. Your senses tell you the planet is huge, that it goes on forever, that there's plenty of everything. Space, resources, air, time. But from 250 miles up, from the altitude of the space station where astronauts live for months at a time, that illusion vanishes completely. Suddenly, Earth doesn't look infinite anymore. It looks small, shockingly, disturbingly small. And here's the part that makes it terrifying. You can see the edge. Not the edge of the land, the edge of everything. Stand on a beach and look at the horizon. You see where the ocean meets the sky. It feels like there's more beyond that line, more ocean, more atmosphere, more world. But from space, you see the actual boundary, the place where the atmosphere just stops, where the blue glow of breathable air fades into black. And when you see that line, when you see how sharp it is, how thin, how fragile, something in your brain clicks, a realization that feels more like a punch to the stomach than a thought. That line, that's all there is. That thin shell of air, maybe 60 miles thick at most, that's the only thing between 8 billion people and instant death. And it looks like you could poke a hole through it with your finger. Let me describe what that looks like, because this is important. Imagine you're floating in the cupola of the space station, the windowed module where astronauts go to watch Earth pass beneath them. You're looking down at the planet, maybe watching the sun rise over the Pacific. The curve of Earth dominates your view. And along that curve, along the edge where the planet meets the blackness of space, there's a glow, a delicate, luminous band of blue. That's the atmosphere, all of it. The entire layer of air that keeps 8 billion people alive, compressed into what looks like a line drawn with a colored pencil. And as the sun rises, that line gets brighter, more vivid, but also more obviously finite. You can see both edges. You can see where it begins and where it ends. And the thickness of it, the actual depth, it's nothing. If Earth were a basketball, the atmosphere would be thinner than the layer of paint on its surface. That's the realization. That's what makes astronauts go quiet. They're seeing, for the first time, in a visceral way, how little there is between us and nothing. An astronaut named Ron Garan described this moment in his memoir. He said that before going to space, he intellectually understood that Earth had a thin atmosphere. He'd seen the diagrams in textbooks. He knew the numbers. But seeing it, actually seeing it with his own eyes, was different. He said it looked like a paper-thin veneer of blue wrapped around a rock. And his immediate thought was, that's it? That's all we have? He described feeling a sudden, overwhelming urge to protect it, not in an abstract environmental way, in a visceral, parental way, like seeing your child standing too close to the edge of a cliff, that instinct to reach out and pull them back to safety. Except he couldn't reach Earth. He could only watch. And that helplessness, combined with the clear view of how fragile everything was, it terrified him. Now, here's where it gets worse. Because the atmosphere isn't just thin, it's all we have. Look in any direction from that space station and tell me what you see. Blackness, emptiness, the void. The moon is visible, sure, but the moon is dead. No air, no water, no protection from radiation. During lunar day, the surface temperature reaches 260 degrees Fahrenheit. At night, it drops to minus 280. Nothing lives there. Nothing can. Mars is a rust-colored dot, and even if you could somehow get there, it's a frozen desert with an atmosphere so thin you'd suffocate in seconds. The atmospheric pressure on Mars is less than 1% of Earth's. That's equivalent to standing at an altitude of 100,000 feet above Earth's surface, 3 times higher than commercial jets fly. Your blood would literally boil. Venus? Closer, but it's a hellscape where the air is poisoned and the surface is hot enough to melt lead. Mercury has no atmosphere at all. Jupiter, Saturn, Uranus, Neptune, they're gas giants with no solid surface to stand on. Their atmospheres are made of hydrogen, helium, methane, ammonia, poisonous, crushing, lethal. The nearest star system is Alpha Centauri, 4.37 light years away. That's 25 trillion miles. If you somehow could drive through space at highway speeds, it would take you 40 million years to get there. And we have no idea if there are habitable planets there. None. This is the context astronauts see. Earth, glowing and alive, surrounded by nothing. No nearby planets we can escape to. No alien worlds offering refuge. Just us. Just this one small rock. Alone in an ocean of darkness so vast that the human mind can barely comprehend it. Carl Sagan understood this feeling. He never went to space, but he spent his life studying planets, analyzing their atmospheres, calculating what makes a world habitable. And what he learned terrified him. Not in a paralyzing way, but in a clarifying way. He realized that the conditions for life, the specific combination of temperature, pressure, chemistry, radiation, shielding, all of it, these conditions are rare, astonishingly rare. We've studied thousands of exoplanets now, thousands, planets orbiting other stars, and we haven't found another Earth, not one. Plenty of gas giants, lots of frozen ice balls, numerous scorched rocks orbiting too close to their stars. But another world with liquid water, breathable air, a stable climate, and a protected magnetic field? Not yet. Maybe they're out there. The universe is vast, but the fact that we haven't found one, despite decades of searching with increasingly sophisticated instruments, should tell you something. Life-supporting planets are not common. And the one we're standing on? It's precious beyond measure. But here's what makes the view from space truly terrifying. It's not just that Earth is rare. It's that we can see it changing, and we're the ones changing it. When astronauts look down at Earth, they don't just see beauty, they see evidence. Evidence of what we're doing. The haze over industrial cities, visible from space. A brown smudge where the air should be clear. The smoke from wildfires burning out of control. Plumes stretching for hundreds of miles. The shrinking white caps of ice at the poles, year after year. The difference visible to anyone who's been to space multiple times. The brown spreading through what used to be green rainforest. Clear-cut sections appearing like wounds on the landscape. And they see it all at once. They see the whole system. The atmosphere mixing and swirling. The oceans absorbing heat. The feedback loops beginning to accelerate. From down here, on the surface, these changes feel abstract. Statistics, numbers on a screen. But from up there, they're visible, undeniable. And they're happening fast. Think about what it means to watch your home change from the outside. Imagine you live in a house your whole life. It's always been there, solid, reliable. Then one day you leave, you go far away. And when you look back through binoculars, you see cracks forming in the walls. You see the roof sagging. You see windows breaking. And you realize for the first time that the house isn't permanent. It's deteriorating. And if you don't do something, it's going to collapse. That's what astronauts feel when they look at Earth from orbit. They see the cracks forming. They see the systems straining. And they come back changed. Many of them become environmental advocates. Not because they've been radicalized, but because they've seen something the rest of us haven't. They've seen Earth as it actually is. Finite, fragile, and in trouble. Let me tell you about something called the Kármán line. It's the boundary between Earth's atmosphere and outer space, defined as 100 kilometers, or about 62 miles above sea level. That sounds like a lot. 62 miles. But put it in perspective. If you live in a city, there's probably another city 62 miles away. You could drive there in an hour. That's how thin the protective layer is. And most of the breathable air, the oxygen we need to survive, that's concentrated in the lowest layer, the troposphere, which is only about 7 miles thick at the equator and even thinner at the poles. 7 miles. If you're on an airplane at cruising altitude, you're already above a third of the atmosphere. The air up there is too thin to breathe. That's why planes are pressurized. And above that, the air just keeps getting thinner until there's essentially nothing left. No pressure, no oxygen, just the vacuum of space. Astronauts see this transition when they launch. They're strapped into a rocket, accelerating upward at tremendous speed, and they watch through the windows as the sky changes color. Blue to dark blue to violet to black. In a matter of minutes, they go from the surface of Earth, where the air is thick and breathable, to the edge of space, where there's nothing. And the transition is sharp, alarmingly sharp. There's no gradual fade. The atmosphere just ends. And when you see that with your own eyes, when you watch the protective bubble of air fall away beneath you, replaced by infinite emptiness, you understand, maybe for the first time, how precarious our existence is. We're living at the bottom of a thin ocean of air, and above that ocean is nothing. No air, no warmth, no life, just cold, empty space that will kill you in seconds if you're exposed to it. Carl Sagan spent years trying to communicate this perspective to people who would never go to space. He knew most of us would never see Earth from orbit, never experience that gut-wrenching moment of realizing how small and vulnerable our world actually is. So he used words, he used images. He fought to get photographs taken from deep space, like the pale blue dot, precisely because he understood that seeing ourselves from a distance changes how we think. And what he wanted us to see, what he desperately wanted us to understand, is that Earth doesn't just look beautiful from space. It looks like it could be destroyed, not by some external force, not by asteroids or alien invasion, by us, by our own inability to recognize what we're risking. Let me give you some context for why this matters right now, in this moment of human history. We're living in what scientists call the Anthropocene, the age of humans. For the first time in Earth's 4.5 billion year history, one species, us, has become powerful enough to alter the planet's climate, its chemistry, its biology, on a global scale. We're changing the composition of the atmosphere faster than it's changed in millions of years. Adding carbon dioxide and methane at rates that have no natural precedent. We're warming the planet faster than most species can adapt. We're acidifying the oceans, melting the ice, disrupting the jet streams, pushing ecosystems past their tipping points. And all of this is visible from space. All of it. Satellites watch the ice caps shrinking year after year. They measure the CO2 concentrations rising month after month. They track the temperature anomalies spreading across the globe. The data is overwhelming. The evidence is irrefutable. And from up there, from that orbital perspective, where you can see the whole Earth at once, the trajectory we're on looks catastrophic. But here's what Carl Sagan would say if he were here right now. And this is important, so listen carefully. The view from space is terrifying, yes, but it's also clarifying, because when you see Earth from that perspective, when you see how fragile it is, how isolated, how precious, certain things become obvious. Things that seem complicated down here on the surface, where we're divided by borders and ideologies and competing interests. From space, none of that is visible. You can't see the borders. You can't see the different nations. You can't see the reasons we give for not cooperating. All you see is one world, one atmosphere, one interconnected system, and everyone is in it together. This is what changed the Apollo astronauts. This is what they call the overview effect. The sudden, overwhelming realization that we're all passengers on the same small vessel. That the air you breathe in Beijing is part of the same atmosphere someone breathes in New York. That the ocean warming off the coast of Australia is connected to the weather patterns in Europe. that the ice melting in Greenland affects sea levels everywhere. From space, these connections aren't theoretical. They're visible. You can watch the atmosphere circulate. You can see the weather systems forming and moving. You can see that everything is connected, that there are no isolated systems, that what happens in one place affects everywhere else. And once you see that, once you really understand it, the arguments for inaction start to sound absurd. Let me tell you about another astronaut, Nicole Stott. She spent 104 days in space, living on the International Space Station. And she talks about this moment when she was looking down at Earth, watching a sunset. The sun was sinking below the horizon, and as it did, the atmosphere lit up, different layers glowing different colors: red, orange, yellow, green, blue, a rainbow of light stretching along the curve of the planet. And she realized that what she was seeing was light passing through the atmosphere at different angles, refracting through different densities of air. The same physics that creates rainbows after a storm, except she was seeing it on a planetary scale. And it was beautiful, but it was also terrifying, because she could see how thin each layer was, how delicate, how easily disrupted. She said it looked like a soap bubble, gorgeous, iridescent, and fragile enough that a single touch could pop it. Carl Sagan studied Venus. He was one of the first scientists to understand what happened there, and it haunted him. Venus is Earth's twin, almost the same size, almost the same mass, formed at almost the same time from the same cosmic material. And if you go back billions of years, Venus might have been habitable. It might have had oceans, a temperate climate, maybe even life. We don't know for sure, but something went wrong. The greenhouse effect, which is a natural process that keeps planets warm, it spiraled out of control. The planet heated up. The oceans evaporated. The water vapor trapped more heat, which released more CO2 from the rocks, which trapped more heat, which released more CO2. A runaway feedback loop. And now Venus is the hottest planet in the solar system. The surface temperature is 900 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure is 92 times Earth's. If you stood on the surface, the weight of the air would crush you like you were a mile underwater in Earth's ocean. And the air itself is poison, sulfuric acid clouds, carbon dioxide thick enough to choke you instantly if the pressure and heat didn't kill you first. Nothing lives there. Nothing can. The planet is dead. And here's the part that kept Sagan awake at night. We're adding greenhouse gases to Earth's atmosphere right now. We're heating the planet. We're pushing it in the same direction Venus went. Now, we're not going to turn Earth into Venus. The mechanisms are different. We're farther from the sun that we have oceans that can absorb CO2. We have a carbon cycle that operates on geological timescales. The processes won't run away to the same extreme, probably, but the principle is the same. Push a planetary climate too hard, too fast, and it can shift into a new state, a state that might be stable, but incompatible with the civilization you built under the old conditions. And from space, where you can see the whole system changing in real time, where you can watch the ice melting and the weather patterns shifting, that risk looks very, very real. Think about ice for a moment. The polar ice caps. From space, they're bright white against the blue ocean and brown land. Easy to see, easy to track. And astronauts who've been to space multiple times, who've seen Earth from orbit over years or decades, they report a disturbing observation. The ice is shrinking, visibly, noticeably. You don't need instruments to see it. You just need eyes. The Arctic sea ice, the white cap at the top of the planet, it's getting smaller every year. The glaciers in Greenland, massive rivers of ice that have been there for millennia, they're retreating. Chunks of ice the size of cities are breaking off and floating into the ocean. And this isn't happening slowly. It's happening fast. Faster than the models predicted, faster than most scientists expected. And here's why that's terrifying. Ice is reflective. It bounces sunlight back into space. That's why polar regions stay cold. But when ice melts and exposes dark ocean water or dark land beneath it, those surfaces absorb sunlight instead of reflecting it. They heat up, which melts more ice, which exposes more dark surface, which absorbs more heat. Another feedback loop. This is happening right now, today, and it's accelerating. From space, you can see it. The white is shrinking, the blue and brown are expanding. And once you understand what that means, once you understand that we're watching the planet's thermostat breaking in real time, it's hard to feel anything but terror. But let's zoom out even further, because there's another layer to this that makes the view from space even more disturbing. Time. We think we have so much of it. Civilization has been around for, what, 10,000 years? We've been recording history for 5,000. We've had modern science for 400. We've had spaceflight for 60. It feels like we've been here forever, like we have forever ahead of us. But put that in cosmic perspective. Earth is 4.5 billion years old. Complex life, animals and plants, has been around for about 600 million years. Humans, modern humans, have been around for maybe 300,000 years. Civilization, the agriculture and cities and writing, that's the last 10,000 years. That's 0.002% of Earth's history. We just got here. We are, in cosmic terms, brand new. And we're already changing the planet on a scale that matches geological processes that usually take millions of years. From space, you can see this in a strange way. You can see the lights of cities at night, sprawling networks of artificial light covering entire continents. From orbit, Earth's night side is glowing. That's new. 100 years ago, there were some lights, but not many. 200 years ago, essentially none. Earth's night side was dark for billions of years. And now it's lit up like a circuit board. That's us. That's human activity, visible from space, undeniable proof that we're a planetary force now. And the question astronauts ask, the question that Carl Sagan asked, is whether we're wise enough to handle that power. Because so far, the evidence isn't encouraging. Let me tell you what Sagan feared most. He feared that we would become powerful enough to destroy ourselves before we became wise enough not to. He saw this tension throughout human history. We invent nuclear weapons before we invent ways to peacefully resolve conflicts. We develop industrial technology before we understand its impact on the climate. We gain the ability to alter planetary systems before we develop the wisdom to use that ability responsibly. And from space, that recklessness is visible. The bombs we've tested, the pollution we've created, the ecosystems we've destroyed, all of it leaves traces, visible traces. From orbit, you can see the scars. And the question is, will we wake up in time? Will we develop the wisdom to match our power before we cross a threshold we can't come back from? Here's another thing astronauts see that troubles them: borders, or rather, the absence of borders. When you look at Earth from space, you don't see lines, you don't see countries, you don't see nations. You see land masses, oceans, clouds, but no divisions. Nothing that marks where one country ends and another begins. And yet, down here, we organize our entire civilization around those invisible lines. We fight wars over them. We build walls along them. We develop weapons to defend them. And from space, it looks insane because the atmosphere doesn't stop at borders. Pollution in one country becomes acid rain in another. CO2 emitted in one place warms the planet everywhere. The oceans are connected. The weather systems span continents. Everything is linked. And yet we act like we're separate, like what happens in one place doesn't affect everywhere else. Carl Sagan believed that if more people could see Earth from space, this tribalism would diminish. Not disappear, but diminish. Because it's hard to hate people on the other side of an invisible line when you can see that there is no line. When you can see that we're all on the same small planet, breathing the same air, dependent on the same systems. He believed that perspective was transformative. That if we could see ourselves as astronauts, see us as one species on one world with one shared fate, we'd act differently. We'd cooperate more, fight less, protect the planet instead of exploiting it. And maybe he was right, because look at what happens to astronauts. They go to space with all their national identities intact. American, Russian, Chinese, Japanese, European, and they come back changed. They come back talking about Earth, not their country. They come back saying we, meaning all of humanity, not us versus them. The experience of seeing Earth from outside breaks down tribal thinking, not completely, but significantly. And it makes you wonder what would happen if everyone could have that experience. If every person on Earth could spend just 5 minutes looking at the planet from orbit, would we still argue about the same things? Would we still prioritize national interests over planetary survival? Or would the perspective shift everything? But here's the reality. Most people will never go to space. The number of humans who've seen Earth from orbit is tiny, about 600 people total in all of human history. Out of the 100 billion humans who have ever lived, 600 have seen Earth from space. That's 0.0000006%. So the question becomes, how do we share that perspective? How do we communicate what astronauts feel when they see Earth from outside? How do we make people understand that the planet is fragile, that we're isolated, that we're running out of time, without sending everyone to orbit? That's what Carl Sagan tried to do. That's what his entire career was about, taking the cosmic perspective and making it accessible, making people feel what he felt when he looked at the data from Venus, or the images from Mars, or the calculations about Earth's atmosphere. He wanted people to understand that we're not separate from nature. We're part of it, that we're not above the rules of planetary physics. We're subject to them, that we're not immune to the consequences of our actions. We're vulnerable, just as vulnerable as any other species. Maybe more so because we've built such a complex civilization on top of such fragile foundations. So when astronauts say Earth looks terrifying from space, this is what they mean. Not that it looks ugly, it's beautiful, heartbreakingly beautiful. The most beautiful thing most astronauts say they've ever seen. But beauty and fragility aren't opposites. They go together. The most beautiful things are often the most fragile. A flower, a butterfly, a snowflake, a newborn child. And Earth, seen from space, is both. It's a masterpiece of cosmic improbability, a living world in a dead universe. The only place we know of where matter has organized itself into consciousness, where the universe has become aware of itself, and it's more fragile than we ever imagined. That combination, beauty plus fragility plus isolation plus visible evidence of damage, that's what creates the terror. Because you realize, maybe for the first time in a deep, emotional way, that this could all go away. Not in some distant future, not in millions of years when the sun expands, but soon, in decades, in your lifetime, in your children's lifetime, and there's nowhere else to go. But let me tell you what Carl Sagan would want you to take away from this. Not despair, never despair. He didn't believe in giving up. What he believed in was the power of perspective to change behavior. He believed that if people could see what astronauts see, if they could feel what astronauts feel, they would act differently. They would prioritize differently. They would stop treating Earth like it's disposable and start treating it like what it actually is. Irreplaceable. The only home we've ever known. The only home we're likely to have for a very long time. And something worth protecting with everything we have. The terrifying view from space is also a gift. It's a wake-up call. It's reality breaking through the illusion. And if we're smart, if we're brave, if we're willing to face what's actually happening, it can be the thing that saves us. Because knowledge is power, perspective is power. And when you know what's at stake, when you've seen it with your own eyes, or through the eyes of those who have, you can't pretend anymore. You can't ignore it. You have to act. Think about what future generations will say about us. Will they look back and say, they knew, they had the data, they had the images from space, they could see what was happening, and they acted in time, they changed course, they protected the planet? Or will they say, they knew, they had the data, they could see what was happening, and they did nothing? They prioritized short-term profit over long-term survival. They argued while the planet burned. Which story do we want to tell? Which legacy do we want to leave? Earth looks terrifying from space because it's small, and we're running out of room for mistakes. Because it's isolated, and there's no plan B. Because it's changing, and we're the ones changing it. But it also looks like something worth fighting for, worth preserving, worth passing on to the next generation intact. And that's the choice we're facing. Right now, this decade, maybe this year, the choice between continuing down the path we're on or changing course, between denial and acceptance, between comfort and survival. Carl Sagan saw that choice coming. He tried to warn us. And the view from space confirms everything he said. We are alone, we are vulnerable, and we are running out of time. But we're not helpless. Not yet. And that's what makes the terror bearable. Because alongside the fear is possibility. The possibility that we might actually figure this out, that we might come together, that we might prove worthy of this incredible gift we've been given, this pale blue dot, this fragile, beautiful, terrifying home, the only world we've ever known, and the only world we're going to get.